Thank you. Welcome to my talk, Oden, a functional programming language for the Go ecosystem. I'm very pleased to be here. It's an honor. And yeah, my name is Oskar Wickstrom. I work and live in Malmö in Sweden. And since November last year, I've been working on this project on my spare time. It's still an experiment, very, very young, so you shouldn't think you can like use this in production when you go away from here. Really, you can't, because it's not usable. So don't expect too much of that. And today we will look at the background for the project, its goals. We will take a look at the current state, a small overview, look at what's coming next, and perhaps we'll have time for 1 or 2 questions afterwards. So, starting with the background. These last couple of years I've been thinking a lot about programming languages, and I'm just going to hit you with some of those thoughts in no particular order. So I want type-safe functional programming for writing servers, web servers specifically. So perhaps Haskell is like the best option for me. I really like Haskell. I don't get along with Scala that much, so it hasn't worked out. Then there is like Rust seems interesting, but the web app development stuff in Rust is not that mature and so on. There may be a lot of other languages that I don't know of, so if you know one that works, just tell me. Yeah, so Haskell is a great language, and to be honest, maybe Haskell is the answer here. Maybe I should just focus all on using Haskell for writing servers. I'm not sure. There's the JSOD framework for Haskell that seems very promising. I haven't kind of dug into it, but I want to do that. Though I think Haskell has some pain points and some problems. The tooling is a bit messy still for Haskell. It's getting there. The Stack project is doing great work. And also the flexibility in Haskell, I think, can be a problem. You have like 100 language pragmas, you have template Haskell and crazy stuff. So having that kind of power can make for like a cognitive overload for people reading the code. And it's like the bag of goodies that is Haskell is a bit too big. So can we have like the safety of Haskell, but in a simpler and smaller language? And by simple and small language, I'm thinking like Scheme is simple and small. So I want to have less of those language pragma stuff to worry about and all those decisions. I want to have like a small set of strong conventions. And here, I think the Go programming language has done, is a great role model in the terms of having strong conventions and not that many types of styles to choose from. Totally different. Do I really need interactive development? And how much complexity does a REPL really bring? So this might be controversial for functional programmers to hear, but first off, I do like REPLs. I really like REPLs. And what I don't like is having kind of strange compile errors and workflow errors because I don't get along with the REPL. And that may be because I'm bad at using a REPL. I'm not sure. But I think they're complex and they're hard. They're easy to mess up in, basically. And if you take the example of closure, I've actually wasted a lot of hours in that REPL, and I feel like I'm forced to use it because I can't go on the command line and like line build or compile or whatever all the time because it's too slow. So I'd rather have fast compilation to begin with and then perhaps a REPL on top. If I had to choose, I would pick the fast compilation. So I think we should optimize for writing code that's correct and readable and safe to change. I don't like chasing down silly programming errors and typos and stuff in runtime. even if it's when I'm developing. Even less so when it's already out in production. I think Haskell is a role model here. It really shines on this. I don't think we should optimize for cleverness. And what do I mean by cleverness? It's like having dense code and one-liners might be very good for yourself and your ego when you're writing it, but perhaps not that practical to maintain and to understand by others and yourself later on. Also, things like hiding essentials in code, hiding implicits, or having implicits, like the magic features of some languages, monkey patching and so on. I think we should avoid those. And it's about making a good trade-off between like the magic aesthetic things and having a certain amount of noise, if you say so. I think you should keep the essentials and hide the non-essentials, basically. And that's what a good abstraction does. It highlights the essentials and hides the non-essentials. And here I'm actually thinking about macros a bit as well, because there's this argument that Lisp or Clojure has only a very small set of forms and syntactic elements that you have to learn, and therefore you can learn it very fast. And while true in some sense, I think Clojure, for example, has a lot of syntax, because the syntax is not only defined in the reader, it's defined in macros everywhere, in libraries and so on. So all that like builds to a very large syntax. Back to web development again, so I'm jumping back and forth. Maybe I could do like static typing on top of JavaScript and Node. Seems to be a good idea. So I tried this PureScript language, really cool. On top of Node, and that works. There's TypeScript and Flow, and there's some kind of new OCaml thing, Reason I think it's called. And as far as I know, all these require some kind of manual FFI bindings to be able to interoperate with libraries and frameworks written in JavaScript. And having to write those FFI bindings to use libraries, that's cumbersome and kind of stalls the early adoption of a language. So perhaps the compiler could do this for us. If we compile to a language that already has a static type system, we could query that type system, and we could have the compiler generate necessary conversions and so on. And can we reuse all the good stuff from Go, but in a functional programming language instead? So there seems to be a lot of people liking to write Go, and maybe I can't convert all of them to functional programmers in Haskell. I don't think I can. So as kind of a social hack, I'm thinking maybe you can just add a language on top of whatever they're doing, so leverage their work. So is that possible? And yes, I think it is. And that's why I started this project called Oden. So why Go in the first place? Well, I think it has a growing and good ecosystem of libraries and tools, and also the standard library. It has goroutines and channels for doing concurrency. You have very easy cross-compilation. You can like compile for Windows on your Mac and so on. You got static linking, and which is very nice for deploying server software, I think. And it's a simple compile target in the sense that the Go specification is very small, and it's a simple language to understand. And then there's also a fast compiler in Go. So as I'm doing transpilation in this project, source-to-source compilation, it works kind of well just to directly invoke the Go compiler, and it's still fast. But there are some things missing in Go. I don't know if you know Go. How many have programmed in Go or looked at it? Okay, basically half. Yeah. So there's this big thing about Go not having generics, Yeah, I won't go there too much, but there's also expressions over statements. I think that should be that would be better. Having like if, for, switch, and even the go statement, which spawns a new go routine. I think there should be expressions instead of statements. You should be able to get something useful back. Generic programming. Okay, so there we go. I will go down this rabbit hole a bit, but Go has no like parametric polymorphism. You can't write generic type-safe code like a map function or a filter function. You have to resort to using the empty interface, which is like object in Java or some other trick. And in the same sense, you can create polymorphic type-safe data structures, like a sorted set that you create on your own for any type. And the Go community seem to have settled at templates and code generation right now. Abstraction. I like to have a monadic maybe type, for instance, to avoid doing nil checks everywhere. I'd like to avoid nil in all. And also error handling. Error handling in Go is explicit in the sense that you return error values. It's not a different thing. So an error is a value returned from a function. That's good. But it's still very tedious and error prone, I think, because they can be nil and you have to check for nil everywhere. So looking at this code, this is it doesn't matter if you see all the text. It's not what I want to show. This is something I wrote a couple of years ago in a project, and if we dim out the error handling, we get something like this. So it's like half the code is error handling here, basically. And those gray parts, if we zoom in, it's this over and over. Just checking if the last thing returned a non-nil error over and over again. I think there is something here we could do better, perhaps. And when I made these slides, actually, I found another problem with my own code. I found this. So here I'm doing an error check, which is totally useless and harmless, but it's still useless because there are no rebinding of error since the last check. And there could be, because the IO copy actually returns an error somehow, so I could bind that. But I missed this, and I'm like, why did I write this code? I have no idea. Basically, I think it's because it's so noisy. It's early exits and error checks everywhere, and I'm just like jamming in at each other command, trying to be super safe or something. And I don't like this. So the project goals for Oden then. Use Go as a platform. And this is like Scala for the JVM or Elixir for Erlang. You could compare to those. Avoid cleverness and prefer clarity. So I'd rather write one or two more lines and have something that's clear than to do like the magical, clever stuff. Expressions over statements, I already mentioned those. It's the if and for. They should return something useful. Support generic programming. So let's skip that writing for loops that actually is a filter or writing a for loop that actually is a map. I think we could have better abstractions than that. And I think there seems to be like a split. Some people think the for loop is easier to understand, and some people think that just having a higher order map or something is easier. And I'm for the latter. And also, I think we can do a lot better than templates and code generation in strange custom tools outside the language. And support good abstractions. I like to reduce the risk of programming errors and stuff that can fail in runtime. You should be able to reuse stable and working code properly without hacks. And being able to abstract things like nil checking and error handling and like boilerplate stuff. I want type inference for basically all code. Still, having type signatures at the top level is a good thing. So perhaps enforce that or at least encourage it very much. But all the rest of the types should be able to be inferred. and I want immutable data structures by default. In the case of Go, you're like encouraged to write programs having thousands or millions of goroutines, doing lots of stuff and passing data over channels and so on. And I think having immutable data structures in that case is a clear win. Pattern matching, I'd like to have that as like the main control flow mechanism. And related to that is exhaustiveness checking. And this is when the compiler helps you so you don't miss any case when you do a pattern match. Simple interoperability with Go. And this is an important one, because if this project is to be successful in any sense, I think it's by doing this. I want to be able to write or use Go libraries without having to write those FFI bindings manually. And also, I like to have a language that's fun to work in. It should be easy for people new to programming or new to functional programming and so on to get into this and have like a good time from the start, not having to write public, static, void, main, class, whatever to get started. And I like having it open source from the beginning. So I published this like when I had 100 lines working out with it, and way too soon it showed up on Hacker News, and the rage began. So that was hard. But even though that happened, I like to have it open and have people being able to see it and contribute and so on. I think that's good. I do not think me shutting myself in a cabin in the woods for like 3 years and programming would be a good result for this. I'm trying to keep this approach of minimum viable product, and maybe this isn't what people talk about when they talk about writing compilers. This is basically how you prioritize your features and different types of writing those features. So you're not only making the functional minimum in the sense that you're doing a lot of compiler features and type system stuff. Also, you make it reliable and usable, accessible, and some amount of emotional, I think, as well. And this affects all the aspects of a project. It's not only the compiler and the language, it's also like the website, documentation, command line tools, and so on. So we're going to look briefly at the current state of Oden, so you get a small feel of where this is at right now. I've excluded some not so important parts, and there's a lot of parts not being that's not done yet. Super simple stuff. It's really silly, so you can't use it for anything productive yet. But I've tried to focus on the things that I'm most uncertain of how they should work. So that's the priorities for this project so far. So we're going to start with hello world, of course. This is a main package, the main function, and it does a print line. And the main function takes no argument and returns unit. Here are some infix operators. So why am I showing you infix operators? They're everywhere, right? But the thing here is that these desugar into something called protocol methods. And I will talk more about protocols very soon, but you can see the rules here. So each of these operators are kind of early in the compiler stage. They're converted to one of these protocols and method, and they're basically like functions. You can think of them as functions. And there's no custom operators, and this ties into the don't be clever thing. So I think you perhaps don't need custom operators. Being able to write like the super double hash rocket Elvis operator, not useful. So there's a set of built-in operators. You can overload those, and that's it. Curried functions. Here we have a sample where the plus function takes an int and returns an int. The twice function takes another function and some value, applies that function to the value, and applies that function again to the result. Plus 20, here we start using decoring. So we apply the plus function to 10, we get another function back. So decoring is that you only have one argument and then you return another function with the second argument and so on. So you can like partially apply them. So plus applied to 10, get another function back, apply twice to that result, get another function back, assign that to plus 20. And then we use plus 20, which is like the composed function, and plus 20 and 20 became 40. So if we add the type signatures for this, we can see what I'm talking about here. Plus function, nothing special. The twice function, you can see it's polymorphic. The for all keyword here is used to introduce type variables into a signature. And unlike in Haskell, you have to write for all A to be able to use A. There's no like implicit type variables based on casing. And plus 20 and 40 is kind of simple. And you can also import packages from Go. So this is what I was talking about with the easy interop and getting started. You can only import a limited set of types right now because I haven't done all the mapping and all. It's basically you have to support most of the Go language in Oden to be able to import it directly like this. But some simple functions work. So here we're importing the HTML package from Go and using a function in it. You can have records. These are very much like records in PureScript or Elm, if you're familiar with those. Basically like statically typed objects on steroids. Here's the type of one of those records. So nothing strange here. But if we have a function taking a record, like this full name function, it takes a person record, it uses the fields first name and last name to build a string. If we infer the type of this, if we don't write the type and be very specific, but infer it instead, we'll get something a bit complex. Looks like this. And what this is that full name is a function with a variable r, and it takes a record which has at least the first name and the last name fields, and possibly more fields bound to r. So why would you want to use this? Yeah, that's because the full name function can take any record that has those. So it's still in the type system that the extra fields. So there's functions like you can extend a record or you can remove fields from a record, and that would be present in the type signature as well. And in PureScript, they have like they're using this at the type level for encoding effects and side effects. So this is called row polymorphism, by the way, and it's polymorphic in the sense that the records can vary in shape. And the last thing I want to talk about is protocols. So they're very similar to type classes in Haskell, if you know that. It's basically kind of ad hoc polymorphism, which is resolved at compile time, and that has some restrictions and some nice qualities as well. It works very well in Oden because we're like compiling to or transpiling to code without any generics or dynamic dispatch in this case. So there's a number of built-in protocols right now in Oden. So a protocol has a number of methods that you implement for a type. Here we implement the monoid protocol, which has two methods, apply and identity. So we're implementing monoid for this record that has x and y int fields. And the definitions come afterwards there. And when we have this implementation in scope, if we do this first or import it, you can create two of these record values, and then you can use the protocol same. Forgot the name. But yeah, monoid apply. You see it there. You can use the polymorphic method name, and these are always qualified like this until I come up with something better. But the good thing here is, as the operator overloading stuff is desugaring into protocol methods, you can also use plus plus, because that's the same. These are equivalent. Yep. And if you're interested in this project and want to find some more information, because this was very brief, you can go and check out the website at oden-lang.org. It has a development blog, some more information, and links to the user guide, which is hosted here if you want to go directly there. I've put some work into this user guide just because I want to try this kind of MVP style Prio thing. And well, many examples in this documentation can be run directly from the browser, and also it's available in PDF formats and so on if you like that. And there's the playground.odenlang.org, which the documentation uses to run programs. So here you can go and try Oden in your browser, basically, and you can see the intermediate Go code, and you can share programs and so on. See the output, of course. You can follow Oden on Twitter, and yeah. What's next? So Oden is an experiment, very, very, very young. There are tons left to do, and as I said, I'm doing this on my spare time, so I've come this far, and I will need help if I'm going to do this. And I think it's like time to take a step back and evaluate this project and see how to proceed and if to proceed. And I really like to hear what you guys think. So if you have some nice input, just come and grab me afterwards, or if you want to get involved or something, just talk to me. And yeah, thank you.
Very nice presentation, Oskar. Does anyone have a question?
Hey, what's the side effect story? Because Go is inherently like side effecty all over the place, right? Like functional languages tend to be not. Like, how do you handle that?
Sure. At the moment, I don't. So you can do side effects wherever you want right now. But I'm trying to figure out how this, maybe using this row polymorphic stuff like they do in PureScript to encode side effects. And the hard part is basically, I excluded that from the talk, but you can't query the types in Go and figure out if they have side effects.
No.
So the user would have to know and kind of themselves annotate it. So I'm not sure how to do that in a good way.
As a language implementer, what do you think are the trade-offs between compiling to another language and compiling to bytecode?
Well, in my case, it's quite simple, because this took me a lot less time, basically. It's simpler because I'm not that good at like doing the compiler all the way down. So it was a simple hack to get something working in the beginning. And in the case of Go, from what I've been able to find, I couldn't find like a standard on calling conventions and so on. So this is the only like safe integration level into Go that I could find, basically. Yeah. Thanks. Good question.
And to expand on the last question, have you ran into any limitations because of the target language, for example, Taylor call optimization, mutual recursion? Do you have to do trampolining or rewrite it all as loops?
Yeah, good question. The loop rewriting is planned because Go doesn't have anything like that. And other things I might have run into. There's some kind of strange thing with their you can't have empty interface stuff in slices, I think it was. But it's not that strange. It has to do with the memory layouts and so on. But yeah, so I've hit a number of these things and have to do some tricks.